All right, families of functions. The first thing we're going to talk about when we talk about families of functions are the parent functions. That's a very important part of graphing any function, is knowing the parent function. So a parent function is the simplest form it's the simplest function with those characteristics. So the parent, right? It's the simplest of all of those functions. So it's the one that starts directly at the center. It's the one that has the most basic slope, the most basic shape, and every other function that is similar to that function is a member of that family. So it has been transformed in some way. So I want you to think back to geometry, and I want you to think back to the definition of translation, okay? So this is the parent function, y equals x. And so that if you think about y equals mx plus b, if I just have y equals x, then that means here my slope must be 1, right? Because 1 times x is x. And if I have nothing written here where b goes, that must mean that it starts at 0. So this is the most basic form, or the parent, of a line. Okay? Starts at 0 and has a slope of up 1 and over 1. Okay, so I'm going to try to do this really freehanding it here without a ruler. So this is the parent function of a line. Okay. This, y equals the absolute value of x, is going to be the parent function of an absolute value function. Okay, again, y equals m times x plus b. So if I have y equals the absolute value of x, then again, my slope must be 1, and nothing here where b is, which must mean it starts at 0. So in the absolute value function, it starts here at 0, and again, each side of your absolute value goes up 1 and over 1. And remember, absolute values are mirror images of each other. They have that line of symmetry right smack down the middle, right? And so that is the parent function of your absolute value. So all other lines are some sort of variation of this line. Either we've moved the line up, we've moved the line down, we've shifted it to the right, we've shifted it to the left, or we've changed its slope and made it more steep or more flat. The same thing goes with this absolute value function. We've either shifted it up, we've shifted it down, we've moved it left or right, or we've made the opening, instead of up 1 and over 1, we've made it much more narrow, or we've made it much more wide and flattened out. So these are your parents. We always start with these. The family is an alteration of the parents. Okay? Like kids in a family. They look a lot like the parents, but they're not exactly like the parent, but they are definitely derived from a parent. Okay, so what we're going to do is we're going to keep thinking about these parent functions, but we're going to do some translating, okay? So I'm going to scroll the page up a little bit. Translating, again, geometry word. When we think about translation, it means to slide, or it means to move a function. So translation from geometry means slide. So we're going to do a vertical slide. Vertical means up and down. So that means we're going to take our parent function and we're going to be moving it up or down. So parent function moved up or down. So the only thing changing about our parent function is the upward movement of it being shifted up or being shifted down. We're not changing its shape. We're not changing its slope. We're just changing where it's moving. So if you think about, again, y equals mx plus b, this tells you your y-intercept, right? And so if this says plus 2, That means that I've taken this parent function, my absolute value parent function, and I've taken the whole thing and I've added 2. So for every point on the parent, and I'm going to put the parent on here, or try to. Okay, here's the parent. For every single one of these points on the parent, I've moved it. I've moved it up 2. So this point has gone up 2. This point has gone up 2, up 2, up 2. You can see this one has moved up 2. That really all we've done is just taken the same shape we had before and we've moved it up 2. So this point got shifted up 2. Blue is your parent, and this is your vertical translation. Okay? Up 2. This one says -3. So now again, we think about what our parent function looks like. Okay? Parent function starts here. And we're going to shift our parent down 3. So again, in a different color, I'm going to show you. This function shifted 1, 2, 3. So all I've done is move the whole thing down 3. Notice that I don't change anything about its shape. Each side still reflects up 1 and over 1. I've just shifted it down 3. Okay? This one I went up 2. That's vertical. Okay, so now let's talk about horizontal. So now we're going to be shifting left or right. So this is going to be our parent function. Moved left or right. Okay, parent function moved left or right. Now, you're going to notice that in this particular case, and these were absolute values that we were moving left or right, or up and down. These are absolute values that we're moving left or right. Here's something very, very tricky about the absolute value. If it's -2 within the absolute value of -2 is 2. If it's 3 positive in the absolute value, it's 3 on the outside. So really tricky in what happens with these functions is that if you're saying x -3, then I'm really not going to be moving to the left 3. I'm really going to be adding 3. You're going to be doing the opposite of what you see inside your parentheses, okay? You do that with both your positives and your negatives. Think about it like this. If I subtracted 3 from the x within my absolute value, what would I need to do to get back to 0? Because absolute value is your distance away from 0. So I took 3 away from where I was. So what would I have to do to get back to 0? I would have to add 3. So instead of subtracting 3, we add 3. We're doing the opposite. So here, remember that it's the opposite when it's inside the absolute values. We must do the opposite. So it's x 1, 2, 3, add 3. Still my parent function, still up 1 and over 1. That part didn't change, but I added 3. Okay, so this is where my parent function would have been. Right? So this is the parent. And then I added 3 to my new function. So this one's +2, which means I'm going to subtract 2. So again, here's my parent, right? And I'm going to subtract 2. So I'm just taking it over. I'm not changing its shape. I'm just moving it over, subtracting 2. Okay, let's move on to the next page. Combined translations. Okay, so now we're really going to try to trick you, right? So we're going to do more than one thing at one time. So more than one movement. Okay, so I'm going to look at this. I always stop and take a moment. This number on the outside means that I'm taking this entire function and I'm adding 3. So I'm going up 3. This on the inside of my absolute value means that I have to do the opposite. So I'm going to go, instead of -2, I'm going to go to the right 2. So to the right 2 and up 3. So this is where my parent function is, right? I have to go to the right 2 and then up 3. This is where I'm going to put my new absolute value function. So I went to the right 2 and then I went up 3. Okay, let's look at the second example. This is telling me -1, so that's saying the opposite of left. So I'm going to go right 1, and again, I'm moving up, so up 2. Here's my parent. Okay, and then I'm going to take that parent function, and I'm going to think, to the right 1, and then up 2. So +1, and then +2. Here's where my parent function, or my, translated function is going to be sitting. To the right 1 and up 2. So that takes care of compound or combined. The next thing we're going to talk about are reflections. And so this is where we are flipping a reflection. Think back to geometry. And a flip or a reflection was where we changed the orientation. So if it was going up, it's now going to be going down, right? We're going to flip the orientation. So the negative on the outside is what's telling you that there's a reflection. Okay. Negative in front means reflection. All right. So negative absolute value of x means that I'm going to take my normal absolute value of x, my parent function, and I'm going to reflect it. So instead of it opening upward, it is actually this time going to be opening downward. Still has the same slope, if I can try to draw it correctly. 1/1. Okay, and so we've flipped it or reflected it over the line of symmetry. So we reflect it over the x, okay? So positive is opening up. And negative opens down. Really important to know. Okay, let's do this one. So first we have to figure out what the original function looks like. So this is telling me if it's +2, then it's telling me to go to the left 2. So my parent function is already shifted to the left 2, and then this negative tells me that it's opening down. So left 2 and opens down. Let's try this. Parent function, right, starts right at the center, up 1/1. Now we're going to be taking that function. We're going to be going left 2. So I'm going to go over here and shift it to the left 2. But this negative is going to tell me that it has to open downward this time. So move it over to the left 2 and then reflect it so it opens downward. Okay. The last one, which is a little trickier, is a stretch or a shrink. Okay. And so let's scroll the page up again. Just a tiny bit more for our last example. And let's think about stretch or shrink. So we're either going to we're going to be taking the parent function and it's either going to become more steep, that's when we stretch it, or it's going to become more flat, and that's when we shrink it. Okay, so let's talk about what's going to happen here. So I want you to look at this and I want you to decide if you think the 2 is going to stretch it out as though someone was holding the parent function right here by maybe they were tacking down this little piece right here, and then they were taking the arrow parts and they were pulling them and stretching them. So pulling them upward, stretching them upward would make this close. This gap would be thinner and thinner if I were to take those arrows and pull them up, right? That would thin it out. If I were to take it and push it down, then that would flatten it out. That would take these arms and squish them and flatten them out, okay? So let me get rid of these little arrows. I just want to make sure that you understood that, the idea between stretching and shrinking. And the pictures will help us when we get there too. So to figure out whether this is a stretch or a shrink, let's do this. Let's plug and chug. Okay, so -2, -1, 0, 1, 2. Since the vertex is right on the axis of symmetry, I chose a few to the left, the actual axis of symmetry, and a few to the right. So the absolute value of -2 is 2, and 2 times -2 is -4. The absolute value of -1 is 1 times, whoops, I just made a mistake. Sorry, let's fix this. I was looking at the wrong spot before I do this. Okay, try this again. The absolute value of -2 is 2 times the 2 we already have here is 4. That's better. The absolute value of -1 is 1 times the 2 I already have is 2. Absolute value of 0 is 0 times 2 is 0. Absolute value of 1 is 1 times 2 is 2. And the absolute value of 2 times 2 is 4. So if I plot these, -2, let me do it in a different color. -2 is now, instead of at 2, it's at 4. -1, instead of being at 1, it's at 2. 0 is still at 0. Over 1 up 2. Over 2 up 4. So you can see that the whole number 2 on the outside is stretching or pulling on my function, straightening it and flattening it out. So number on the outside of my absolute value function, if it's a whole number, it's a stretch. Okay? Now, some students find this a little bit confusing. If you just use a chart like this each time, you'll be certain to know the difference. Let's go ahead and try this one. Okay, I'm going to go ahead and put my parent function in before I even get started. Okay, here's my parent. And then again, I'm going to do when x is, and I'm going to go ahead and plot some of these. Now, since there's a 3 here, I'm going to choose numbers that are divisible by 3 because I want this to be easy math for me. So I'm going to do -3, 0, +3, and then maybe I'll do 6 as well, and then I can always mirror it for -6. So absolute value of -3 is 3, and 3 times 1/3 is 1. Absolute value of 0 is 0 times 1/3 is 1/3. Oh, sorry, is 0. I'm having a rough day today. Holy moly. Is 0. Okay. 3, absolute value of 3 is 3 times 1/3 is 1. Absolute value of 6 is 6 times 1/3 is 2. So let's go ahead and do this in a different color. So we're able to see at -3, I'm at +1. At 0, I'm at 0. At 3, I'm at 1. You can see this is a mirror image. At 6, I'm up here at 2. So at -6, I would also be up here at 2 because it's a mirror image. So now you can see that when the number on the outside of my absolute value is a fraction, that means that we're shrinking it. Okay? And again, use the chart to help you if you're really getting stuck. Okay? So here's a summary for you, just to kind of surmise what we've been talking about when you look at a function, y equals mx plus b. Okay, so that's whether it's a line or whether it's an absolute value. Okay, now, I know this looks a little weird. This is linear, and this is absolute value. So what I want you to remember are these things. Slope, okay. Slope is just like stretch and shrink. Okay. This number inside the parenthesis, remember, is your left and right movement of your absolute value, and remember that that is based on the opposite. Okay, and I'm sorry I ran out of space. You could probably tuck it right down here, but my board is in the way. Maybe I can make it smaller. Here we go. So left or right movement. And remember, it's backward. Left is positive and right is negative. And then these numbers on the outside, this is your up or down, right? Same thing here, up or down. So sort of the general equation, and then what those numbers are telling us to do.